Hello, physics DC circuits. Parallel and series combination of resistors. Determine the equivalent resistance, first part, and the voltage across each resistance of this circuit. This circuit is given. So R1, R2, R3. R1 is 820, 680, 470 ohms, and the EMF is a 12 volt battery is attached to this one. So this potential is the same for this one, these two, R1 and R2, R1 and R2, same potential, difference. So R1 is parallel to R2. So the equivalent of this one, so it will be in series with this one. So equivalent resistance of R1 and R2 is R equivalent 1, 2. So that will be in series R equivalent 1, 2 in series with R3. So equivalent of all 1, 2, 3 is equal to the equivalent of R equivalent 1, 2 plus R3, where R equivalent of this one is R equivalent 1, 2 is 1 over R1 plus 1 over R2 whole inverse plus this is this one, and if you add plus R3, this one is equal to R1, 2, 3. So R equivalent of this one, this is equal to 372 ohms. So if you add this one plus this one, 470. So this is R equivalent of 1, 2, 3, and this is equal to 800 to 14, 7, 842 ohms. So this is the first one. So R equivalent of this circuit is 842 ohms. This is the first part. So this is the equivalent, and the B, the current I is flowing from this one. We can find this one in the circuit. So V is equal to IR, V is equal to IR. So I is equal to V is equal to IR, and I is equal to V over R. So I is equal to, so IMF over R equivalent. So this is the total current flowing, this one. So this is a 12.0 volt divided by 842 ohms. So the current is equal to 1.4 to 1.42 into 10 power minus 2 ampere. So this is the current. So the voltage across R3 is equal to IR. So I and R3. So this is equal to 1.42 into 10 power minus 2 amp multiplied by 470 ohms. So VR3 is equal to 6.7 volt. So 6.7 volt is this one across this one in R3. So there are two combination equivalent 1, 2 and R3. So R3 has 6.7 volt and total is 12.0 volt. So that means this should be 12 minus 6.7 and which is equal to 5.3 volt. So this is equal to 5.3 volt. So 5.3 volt is in equivalent. So this is the answer. So a voltage at R1 is equal to voltage at R2 is equal to 5.3 volt, and voltage across R3 is equal to 6.7 volt, and also voltage from this one, this equivalent can be found voltage equivalent 1 2 is equal to IR. So IR equivalent 1 2. So I is this one. I is this 1.42 10 power minus 2 amp into the equivalent is this one 372 ohms, and this will also give you 5.3 volt. So this is the same as this one. So this is the result of this question. So these two are equal parallel. In parallel is in series. The result of this one is in series. So R1 2 in series with this one. So R1 2 3 is this one in series. So that means R3 plus equivalent of this one. Equivalent of this one is this one. This is plus R3. So this is this plus this one. So R3 plus equivalent of this one. That will give you the equivalent of the whole circuit. Then find the current and then find the potential difference of across each other resistance.